A lone sarsen, half buried on the Salisbury Plain, catches the morning light, its weathered surface still bearing the faint imprint of ancient tools. Nearby, a 5,000-year-old burial pit reveals a crouched skeleton whose bones whisper of a community that once gathered here. Researchers have long wondered which people raised these stones, but the answer lies buried in their DNA. Yet the story is far more tangled than a single tribe, and the next clue emerges from a chipped axe. When archaeologists brushed away centuries of soil at a roadside barrow, they uncovered a polished stone axe, its haft still tinged with ochre, lying beside a crouching skeleton. The axe's wear pattern suggested was used for both felling trees and ceremonial rites, hinting at a society skilled in both agriculture and monument building. Radiocarbon dating places the burial at roughly 8,000 years ago, aligning with the earliest phases of Stonehenge's construction. Yet this tangible artifact only scratches the surface of who the builders truly were. Around 8,000 years ago, families settled on the Thames floodplain, cultivating wheat and barley in fields that stretched to the horizon. Their surplus fed crews who dragged massive sarsen blocks from distant quarries, stacking them in circles that still puzzle modern eyes. These early farmers left behind longhouses, storage pits, and a network of cost-weight enclosures, evidence of organized labor and shared belief. Still, the genetic fingerprints of these people remain elusive, prompting scientists to turn to ancient DNA for answers. In a quiet laboratory, researchers extracted minute DNA fragments from the teeth of dozens of Neolithic skeletons, each sample a fragile thread connecting past to present. Sequencing revealed a genetic profile dominated by early European farmer ancestry, distinct from later arrivals from the continent. The data, however, represent a limited cross-section of burials, not the entire living population, and cannot reveal how those communities lived or died. Still, these molecular clues begin to map the population that erected Stonehenge. Around 2450 BCE, a new genetic signature, traced to steppe herders from the Eurasian plains, first flickers in British skeletal remains, like a fresh pigment added to an ancient mural. This ancestry arrives with individuals bearing the characteristic Beaker pottery style, suggesting a wave of migration rather than mere cultural exchange. The genome-wide estimate indicates that within a few centuries, roughly 90% of Britain's gene pool shifted toward this newcomer profile, though the figure reflects an average across generations, not a single cataclysmic event. DNA alone cannot tell whether disease, social change, or other forces drove the transition. A cracked rim of Beaker pottery emerged from a chalk burial mound near the South Downs, its glossy surface still catching faint traces of ancient resin. The fragment style matches those found in Iberia and Central Europe, yet genetic analyses show those distant Beaker groups were only loosely related, implying the pottery spread both by movement of people and by trade networks. As the shard sits beside a bronze dagger, scholars ask whether its owners were newcomers who reshaped Britain's genetic landscape, or locals adopting a fashionable cup. The answer may lie in the next set of ancient genomes. When a shard of Beaker pottery was unearthed at a hilltop site in southern Germany, the archaeologist noted the vessel's distinctive bell shape, but also subtle local decorations. That mix of shared form and regional flair tells us ideas moved faster than people, and that the Beaker phenomenon was never a single marching tribe. Yet the pattern hints at a network of exchange, not a monolithic culture. In a climate-controlled lab at the Max Planck Institute, technicians powdered the teeth of 400 individuals ranging from early farmers to Bronze Age warriors. By sequencing the fragments, they built a chronological genetic map that shows how ancestry rose and fell like ocean tides over 3 centuries. Each genome acts as a timestamp, letting us watch the invisible flow of peoples across the British Isles. Among those 400 ancient genomes, 226 came from graves where a beaker cup lay beside the skeleton, a direct material link between the pottery style and the bodies that carried its DNA. The presence of the cup in the burial suggests the individuals identified with the new cultural package, and their genetic signatures reveal a striking influx of steppe-derived lineages. When diggers opened a shallow barrow on the Kentish coast, they found a young adult tucked in a stone-lined chamber, a polished beaker cup resting on his chest. Microscopic analysis of his teeth showed a sudden surge of steppe-related DNA, a genetic fingerprint that had been rare in Britain just a generation earlier, marking the first foothold of the incoming wave. Around 2450 BCE, a sudden spike in steppe ancestry appears in the British genetic record, prompting scholars to ask whether whole families crossed the Channel or whether ideas simply traveled. The abruptness of the shift, captured in a handful of burials, leans toward a movement of people, yet the archaeological record still shows local traditions persisting alongside the new style. Genome-wide analyzes estimate that roughly 9/10 of Britain's ancestry was replaced within a few centuries after the Beaker arrival. But that figure is a genome-wide estimate across generations, not a single catastrophic event. DNA cannot tell us whether the change resulted from disease, differential birth rates, or outright conflict, and the sample comes from burial sites, which never perfectly represent the living population. When archaeologists examined the DNA of individuals buried just after the Beaker arrival, they found that roughly 9 out of 10 genetic lineages traced back to newcomers from the continent. This genome-wide estimate spans several centuries, not a single moment of conquest. It shows a sweeping demographic shift, but it does not tell us how the change happened, whether through conflict, disease, or differing birth rates. Researchers plotted ancestry components for each ancient individual, stacking Neolithic farmer, Western hunter-gatherer, and steppe-derived strands side by side. The bars shift dramatically after 24,000 BCE, with steppe ancestry soaring while farmer signatures fade. By visualizing the data this way, the study highlights how quickly the genetic makeup of Britain transformed, even though the underlying human stories remain hidden. Scientists compare thousands of DNA markers across dozens of ancient skeletons, then model each person as a mixture of reference populations. The analysis revealed that Iberian and Central European beaker groups, despite sharing pottery styles, carry only loose genetic ties. This suggests that the beaker phenomenon spread through both the movement of people and the exchange of ideas, rather than a single, uniform migration. The team extracted DNA from teeth and petrous bones recovered in barrows, cemeteries, and settlement pits across southern England. Each sample represents a single individual who was buried, not a random slice of the living population. Because burial practices differ over time and region, the data set inevitably skews towards certain social groups, leaving gaps in the full picture of who lived there. Even with a dramatic genetic turnover, ancient DNA cannot pinpoint the cause. The method reads ancestry, not trauma, and cannot differentiate a massacre from a slow demographic drift. Likewise, disease outbreaks or cultural preferences for larger families could produce similar patterns. Therefore, while the numbers are striking, they remain silent on the human experiences behind the shift. Archaeologists uncovered a bustling workshop on the edge of the Salisbury Plain, where flint blades and polished axes lie scattered on a compacted earth floor. The tools bear wear marks indicating they were used to shape the massive sarsen stones that would become a monument. Workers likely belonged to the Neolithic community that raised those stones, yet none of their descendants dominate today's gene pool. Around 4,000 years before the Bronze Age, farming villages dotted the British landscape, their fields marked by long barrows and causewayed enclosures. These groups practiced a shared ritual language, exchanging amber and pottery across the channel. Their DNA, captured in skeletal remains, shows a continuity that stretches back to the first European farmers, suggesting a relatively stable population for millennia before any major influx arrived. Radiocarbon dating places a sharp demographic shift at roughly 2450 BCE, when individuals bearing steppe-derived ancestry appear in southern England graves. The new genetic signature differs markedly from the earlier Neolithic profile, indicating a replacement rather than a simple admixture. Within a few centuries, the ancestry that once defined the island had been largely supplanted, reshaping the genetic landscape. Recent genome-wide analyses reveal that only a small fraction of present-day Britons carry the distinctive Neolithic genetic markers of the people who erected Stonehenge. The study estimates that roughly 90% of the island's ancestry was replaced after the arrival of the Beaker groups, leaving the original builders as a genetic minority. This does not imply a singular violent purge. The data reflect broad reproductive shifts over several generations. Excavations in southern Spain reveal beaker vessels adorned with vivid orange spirals, their rims painted with mineral pigments that still sparkle under museum lights. Far to the north, in the lowest plains of modern Germany, the same pottery shape appears, but the decoration is restrained. Subtle bands of incised lines and muted ochre washes. The contrasting aesthetics hint at distinct cultural spheres despite a shared vessel silhouette. Genomic sequencing of burials across Europe splits the Beaker phenomenon into two principal lineages. Individuals from the Iberian Peninsula carry a Western genetic profile linked to earlier Atlantic farmers, while those from Central Europe display a strong steppe component tied to the Yamnaya migrations. The split suggests that Beaker pottery spread through both migration of peoples and the exchange of ideas across trade networks. Archaeologists examine the DNA of individuals buried with Beaker pottery in the Iberian Peninsula and in Central Europe. The genome shared almost no common ancestry, a pattern that emerges only when thousands of genetic markers are compared. This stark genetic divide tells us the two clusters arose independently, yet both wore similar ceramics. The question now is how such parallel styles spread across the continent. In coastal settlements of southern Britain, researchers found Beaker shards alongside native Neolithic tools, suggesting exchange through trade routes. Further inland, burial sites reveal a sudden surge of steppe-derived ancestry that mirrors the arrival of the pottery itself. These contrasting patterns indicate that in some places the style traveled through hands, while in others it arrived on the backs of migrating peoples. What drove these differing mechanisms? A vivid fresco discovered in a burial chamber at a hill fort in western England depicts warriors, animals, and swirling geometric designs. The pigments, derived from locally sourced minerals, were applied with brushes made from animal hair. Yet the individuals interred beneath the mural carry DNA that aligns more closely with continental migrants than with the earlier inhabitants who painted the scene. The artwork becomes a silent witness to a profound demographic shift. When a fragment of ancient tooth is placed under a microscope, the resulting genetic code can rewrite entire narratives about past societies. DNA reveals migrations invisible in the archaeological record, uncovers hidden relationships, and quantifies ancestry changes over centuries. By integrating these molecular clues with pottery styles and settlement patterns, researchers can separate cultural diffusion from population replacement. This scientific lens is turning long-standing assumptions on their heads. The massive sarsen stones of Stonehenge still dominate the Salisbury Plain, but the people who erected them left few genetic traces in later British populations. Genome-wide analyses show that, after the arrival of Beaker groups around 2450 BCE, roughly 90% of the gene pool shifted within a few generations. The original builders were almost entirely displaced, their descendants becoming a small minority in their own homeland. Standing beneath the ancient circle, visitors often feel a direct connection to the stone-laying ancestors. Yet the DNA evidence tells a different story. Those ancestors were largely replaced by newcomers who brought new customs and languages. This revelation reshapes how we view national identity, reminding us that cultural heritage is a mosaic built by many peoples, some of whom have faded from the genetic record but live on in stone.